Hi, I'm Chelsea, and today I'm going to demonstrate how to solve a force problem in physics. So to begin, let's first look and see what this problem is asking. Okay, so in this problem we have a box, and on this box there are two forces acting on it. Force 1, which is directly in the positive x direction, which has a magnitude of 8 newtons, and then there's a second unknown force that I called F2. And what we are trying to find in this problem is the magnitude of F2. Some other things we know about this box. One, we know that it is only accelerating in the y direction at 3 meters per second squared. And we also know the mass of the box is to be 3 kilograms. Okay, so going back to this picture, as I said before, what we know about this box is that it is only moving in the y direction. Therefore, there must be some force acting on the box to move it upwards. Okay? It is not moving left or right horizontally, so we also know that there must be some force counteracting the known F1, which is moving it in the positive x direction. And that is why I drew this F2 force to be upwards and to the left. There is some component of F2 pulling it up, and another component, as I said, pulling it left to counteract this F1. I've also drawn a coordinate system where I made upwards to be y, positive y, and to the right to be positive x. Okay, so let's look again back at this F2 force. I am going to flip out and draw a nice triangle. So this F2 force pulling up and to the left will have an x component and a y component force. And it's very important that we right away draw this triangle because we will need this when we start to put it into our two separate net force equations. So doing that, let's first look at the net force in the y direction. The only force acting in the y direction is this F2y, which is pulling our box upward. Okay, and again, the net force is equal to the mass times the acceleration in the y direction. For our x direction, we have two forces acting here. So the first force we have to worry about is this F1, which is pulling it to the right, so that'll be positive. And then pulling it back to the left is the x component from this F2 force. So I'm going to use a minus sign to represent that this force is acting to the left. And again, that will be equal to the mass times the acceleration in the x direction. So one nice thing happens when we look at this equation here. Our box, again, is not moving left or right, so the acceleration must be 0. So this whole thing equals 0. And as soon as we see that, we can actually solve for F2x by moving it to the right side, so that we get F2x is equal to F1, which we know to be 8 newtons. So we already have the magnitude of this component. Okay? Taking a step back and looking at what happened here, fortunately our problem gives us the mass and the acceleration in the y direction. So right away we can write that F2y will equal our mass, which is 3 kilograms, times the acceleration in the y direction, all equaling 9 newtons. Alright, so we've done kind of the hard work of this problem where we have found both the components of this F2 and the X in the Y direction. So now we're going to use a little more trig, and we're going to write for the Pythagorean theorem that because this is a right triangle, we'll get F2 squared, so the magnitude of this force squared is going to equal F2x squared plus F2y squared. Okay? So this is giving us a relationship between the magnitudes of each component and the magnitude of that total force. Putting in the numbers, we'll get F2 squared. It's going to equal 8 squared plus 9 squared, which totals to be 145 newtons squared, just to make sure we carry our units. And taking the square root, we can find the magnitude of F2, which equals approximately 12.04 newtons. And there's our final answer. So in this problem, I have demonstrated how we first drew a force diagram, including our coordinate system. We next wrote out our two net equations for forces, separating them into X and Y coordinate systems. And then we solved for what we needed for the problem by analyzing this triangle and knowing we needed each of these F2x and F2y, the magnitudes of those two separately, ultimately giving us the magnitude of this unknown force. And that's it. For more information, please visit our website at www.sandersontestprep.com. The link is in the description box below. Thank you.